the parent function is the most basic function in a family. Okay, so in other words, right, it's super, super basic. And if we look at our linear, okay, if we look at our linear, so I'll rewrite that one for you. That was our y equals ax plus b. If we get rid of all of the extra stuff, okay, our stripped down parent function, all right, our parent function, when we get rid of all the extra stuff, is that y equals x, right? Y equals x, okay? And if we were to look there, okay, we would plug in our inputs, which would be our x variables, and we could get out our y variables, which is our outputs, okay? And this is going to take a little bit of time here, so I want to just go through a couple, okay? If you plug in 3, you're going to get out 3. You plug in 2, you're going to get out 2, right? 1, -1, all that stuff. And we're going to end up with that linear, that straight line, okay? And for our linear parent function, it has 4 specific characteristics that make it a linear function, okay? And the first one is it's a straight line, right? There's no bends in the line. All right, the second one is it goes through the origin, and if you forgot, the origin is that 0, 0. Okay, it has a slope of +1, right? Slope being our change, our change in y over our change in x, right? So how high are we going versus how far are we going, right? Our vertical change versus our horizontal change, all right? And it's in quadrants 1 and 3, all right? And if you're unfamiliar with that, again, you could always look up on Google quadrants on a graph, all right? But quadrant 1 is in the right corner, 2, 3, and then 4, all right? So these are the basic characteristics that identify this as a linear line, right? And it identifies it as our linear parent function, okay? Now moving forward, when we look at quadratics, all right, if we get rid of all the extra variables and all the extra letters, right, the thing it has to have in order to be a quadratic is this x squared term, right? It has to have that x squared term. If we have that plus bs or that plus c, awesome, right? But those are just extra things adding on to this original basic parent function, all right? So if we do this, right, 3 squared is 9, 2 squared is 4. Even when we get down here, when we get -1 squared, it's going to give us 1, right? Because -1 times -1 is +1, and -2 squared is 4, all right? And we end up with, that U shape, right? We end up with that U shape. And so a couple of the characteristics of quadratic parent functions is it's got that parabola U shape, right? So our parabola shape, its vertex, right? That minimum point where it changes direction is at the origin. And then it's in quadrant 1 and quadrant 2. Okay, so it's in these top 2 quadrants here, all right? And those, again, are the 3 characteristics that identify this as a quadratic function, and specifically a quadratic parent function. All right. Now, absolute value functions. Okay, we've talked a little bit about it, and I'm hoping that you guys learned a lot more about this in like your Algebra 1 here. But for your absolute value function, right, it's those 2 straight vertical lines. Okay, so those 2 straight vertical lines. And what happens is that's, again, how far away you are from the 0 line, right? And when we talked about this, they talked about the balance beam. So whether you took 3 steps forward or 3 steps back, your still absolute distance that you moved was 3, right? So if we look at the absolute basic version of this graph here, okay? Absolute value of 3 is 3, 2 is 2, 1 is 1, 0 is still going to be 0, all right? But where this changes is in our negative values, right? Even if I take 1 step in the negative direction, right? When I have my y value there, it's still only seen as 1 step, right? So again, I've moved 2 away. It doesn't matter if it's in the negative direction, it's still 2. right? And what this is going to look like is this V-shaped graph, right, where it points at that 0, 0. Okay, so again, the characteristics of this absolute value parent function is that it's got that V shape, right? So it's no longer curved. It makes an abrupt change at 0, 0. Negative, negative, stop, abrupt change at 0, 0. Okay, it's vertex, right? So this is still considered a vertex. It's the minimum point of the graph is at the origin, all right? And then it has a slope of +1 on the right half, right? So it looks like our linear line there, but it has a slope of -1 on the left half, right? So it looks like our linear line here, but the difference becomes is that the left half of the graph is in quadrant 2 with a -1 slope, all right? So again, it's in quadrants 1 and 2, and that's what makes it different than the other values there. Okay, and then the last main one here is this thing called reciprocal, right? So 1 over something, 1 over something. And again, it's represented by the fraction 1 over x, 1 over x. And I talked a lot about this in the video yesterday, but I want to make sure that it is completely clear. All right, 1 over x. You could also have this by saying x to the power of -1, okay? I'm trying to find mine to the negative, there you go. All right, so x to the negative first power. Oh, there we go, there's a 1. All right, so that's saying the same thing there, right? It's saying I have x to the -1 power is 1 over x, right? And we talked a lot about this yesterday. So if I have 1 over, let's go with y squared, this is like saying y to the -2, all right? But this 1 over something is the reciprocal, right? It's the reciprocal. And in the most basic form, it's this 1 over x. Okay, so in the basic form in this parent function, it's this 1 over x. Okay, and so what that would look like, what that's going to look like graphically is my x value, if it's 4, it's 1 over 4, 1 over 2, 1 over 1, 1 over a half, right? We start to have this kind of sloping shape here. All right, but what happens is now I have -1/4, -1/2, -1. You can kind of see it's looking like I'm gonna have 2 very similar shapes there. All right, and you do, right? You have 2 very similar shapes, except you notice that you're never gonna get towards that 0. And so we'll talk about that right here. All right, and the reason that is because the graph of 1 of x, it doesn't go through the origin because you cannot divide anything by 0, right? We tried it. Even if you type it in your calculator, 1 divided by 0, it's going to tell you error. All right. So it ends up giving us these two lines here, and together these curved pieces are called hyperbola. All right, a hyperbola. All right, and then it does not go through the origin, and the other characteristic is it's in quadrants 1 and 3. All right, so does not go through the origin. It's in quadrants 1 and 3, and honestly, it looks like it's reflected through, because it is. It's refracted through this negative y, negative x line here. Okay, looks like it's reflected through this y equals negative x line. If I were to draw a vertical line right here, right there, it looks like it's reflected across that line. Okay, and then there's a couple other functions here that we'll briefly mention, but we're not going to focus on, just so that you can see what they look like and you're not surprised if you see them somewhere. But the first one here is this exponential. Okay, so exponential means a to the power of x, right? So a to the power of x. Where again, if I plug in x equals 2, this is a squared. X equals 3, a cubed. All right. Another one here is square root, right? So we've worked a little bit with this here, but if you have the parent function is the square root, it's going to give you that top half of what we looked at for our reflected parabola, okay? So if we looked at, remember we said our parabola was shaped like a U, then when we had the inverse of that, right, we had both sides. But if our parent function is just this positive version, it's going to have just the top half of that shape. Okay, and then the last one here is this thing called logarithmic. All right, and we'll talk more about logs moving forward, but this thing's called a logarithmic parent function. So you have log A of 10, right? And we'll worry about that later, but you can plug this into your calculator and it will give you a shape of a graph that looks like this for different values of X. All right. So then just confirming what we've learned. All right, so if you know a parent function, if you know what that will look like, you can understand the entire family of functions, right? So now understanding what basic X squared looks like, when I start adding things on, it'll help me understand what all of those different functions are going to look like. All right, so then what are the characteristics of the graphs that are in common with the different functions? Here's kind of your breakdown, right? And this is also what's in your study guide, okay? This quick little summary sheet. Linear, straight line, goes through the origin, slope of 1, it's in quadrants 1 and 3, all right? And you have that for the 4 main ones that we're gonna talk about here. So the 4 are linear, quadratic, absolute value, and that reciprocal, okay? So then if we move forward here, all right, so the absolute value parent function, right? You got to know that that equation is with those vertical lines, okay, those vertical lines. The linear parent function, that's just where y equals x, all right? For our quadratic parent function, our quadratic, that's our x squared, right? Because that x squared is our quadratic term. And then that reciprocal, which may be new to us, is the 1 over x. Okay, it's the 1 over x. So it's always going to look like those equations for these different parent functions, okay? So I'm not saying you have to memorize them, but if I ask you what a linear parent function is, you have to be able to tell me that f of x equals x or y equals x. Okay? You've got to be able to know these or to be able to find them rather quickly, okay? So this one here is about checking off to make sure that you really understand. So which of the following is not a characteristic of the graph of a linear parent function? Okay, well, we know that a linear line is going to be a straight line, right? It's going to look something like this. It's going to have a slope of 1. We just said that. It's in quadrants 1 and 3, and it goes through the origins. Okay, it goes through the origin. All right, so it is a straight line, has a slope of 1, and it goes through the origin. So the one that it's not is the quadrants 1 and, oh, and I lied to you, I'm sorry. In Roman numerals, IV is 4. All right, in Roman numerals, IV is 4. So again, in our little quadrant box here, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4 there. All right. So the answer to this one is C. All right. Moving forward here, what parent function does not go through the origin? Okay, which parent function does not go through the origin? All right, and obviously y equals x, that linear goes through there. Okay, we had our other functions, which were our quadratic, right? We had our quadratic, we had our absolute value, and then we had our reciprocal, right? And knowing the basic shapes of those, the answer for this one is going to be our reciprocal. All right, what is the shape of the absolute value parent function? It is that V shape, right? V shape, you got it, and this one's important again because it's a sharp turn at 0, 0. It's no longer curved. And then which of the following is not a characteristic of the graph of the quadratic? So looking at this one here. Okay, it is in quadrants 1 and 2. It is a parabola. It does go through the origin. The one thing it's not is it's not 2 separate graphs. Okay. And hopefully you find this section here kind of easy, because again, we build off of this for a lot of the units moving forward here. Okay, we've got to understand the parent function so we can understand the rest of those within that unit. Okay, so then to go through this quickly here, okay, the function family, a group of functions that share similar characteristics or features. All right, the most basic function of the function family is the parent function. All right, and then being able to identify based on what the graph looks like. So this one is our linear function, and its parent function is y equals x, right? So every time y equals x is going to look like this. This is our quadratic, y equals x squared. This one is our absolute value, y equals those straight vertical lines, x. And then our reciprocal, our 1 over x, right? And those two curved shapes that don't go through the origin. All right, looking at this one, again, this one is straight based on that summary chart. So I'll let you guys fill that out on your own for the sake of time here. And moving forward with our practice problems in our concept check, or check up, sorry, in our checkup. Write the correct parent function, okay? So this is, again, just being able to identify what the different functions look like, okay? And I know it's not a difficult question here, but you are going to get asked that on your quiz. So you've got to be able to either have these off the top of your head, or again, have them written down somewhere so you can use them. All right. Which parent function is represented by the graph here? Again, that's just pointing out basic identities here. So this one is the reciprocal, or y equals 1 over x, okay? And I knew that. Oh gosh, I lied to you. Wow. Ooh, got confident there. All right, sorry, this one is the absolute value, okay? And I knew that because of the V shape, right? I knew that because of the V shape. So this one is my y equals absolute value of x. All right, and again, if you're unsure, pick which equation you think it is and then plug in a point. So if I have my -10 there, okay, it's at positive 10. So I would plug in y is equal to 10. Is that equal to the absolute value of -10? And the answer is yes, 10 equals 10, right? So I'm sure I've got the right parent function there. All right, but you also have to be careful. You might want to check multiple points on both sides here, because you got to make sure that it's not you're not overlapping some of them. For example, here, if I picked 10, 10, all right, so 10 is equal to the absolute value of 10, right? Well, great, we know that. But if I were to also look at the function for a linear line, that would also work for a linear line, okay? So the difference really comes in looking at both sides of this graph here and knowing that V shape is the absolute value. All right, now this one is our quadratic, right? So our y equals x squared. Oh, and it even gave us answer choices. Sorry, I didn't notice that. It gave us answer choices. So first one there, absolute value. Second one there, our quadratic. All right, our third one here is the reciprocal parent function, and the fourth one there is our linear line, right? So our reciprocal being y is equal to 1 over x, and our linear y equals x. Okay, and then just 9 and 10 here. Okay, which parent function does not have a graph that goes through the origin? Okay, that was our reciprocal parent function, okay, because it gave us that two separate shapes that made our hyperbola that didn't go through 0. And then which parent function has a graph that is a parabola? That would be our quadratic, okay? And again, I know hopefully this unit isn't super difficult, but the point is for you to be able to use this, because in the next lessons here, we're working with really modifying those and figuring out how to make changes to these parent functions, okay? So for this one, you only have this quiz here, okay? So you have the one quiz, you are gonna do it for this unit here. And then we'll move on to the next one here. All right, so you have one quiz for this parent functions unit, and then you had only one quiz here for graphs of inverses. So right now you're at two quizzes. All right. And my goal here is to get us through this shifting functions unit. We've got 30 minutes, so we're gonna get through this one. So it looks like we're gonna cover 3 out of 4 of our units here, and the 4th one I will make and release a video for you after class today. So we'll work on getting this shifting functions here. All right, and what they're starting with here is talking about how we can have a parabola that looks exactly the same. So if I were to overlap them, they would be identical, except for we can do this thing called shifting, right? We can move the location of one of these parabolas, right? And so that's why we have to understand what the parent functions look like, because our parent functions are going to tell us, all right, well, we're always starting here, but this one is moved to the right or down or left or down and left. Right, so that's talking about this thing called shifting functions. All right, so really dealing with the graph's location. All right, so again, if you slide a pencil on your desk or your pen on the desk, it doesn't change the shape, doesn't get longer or shorter, it's still a pen. The only difference is that it's at a different location. All right, we can do the same thing for functions here. So like I said, we can shift down left, down right, we can shift up, we can move right only, right? All these different things. So these are examples of shifting graphs. All right. So then there's 2 ways to shift a graph, vertically and horizontally. Okay. And yes, you can shift vertically and horizontally, and that does make it diagonal. I get that. Okay. But when we're talking mathematically, we only really talk about either shifting vertically or horizontally. Okay. So if we're shifting vertically, that's talking about going up and down on a vertical line. All right, so the red graph there was shifted vertically down. Okay, and all we're doing when we shift is changing the location, not the shape. All right, and so when we look at this with actual values, okay, if we shift this guy, all right, what we can see here is we increased each y coordinate, right, the vertical coordinate, by 1 point. So instead of being at -1, 1, we're at -1, 2. So that went up by 1. Same thing, 0, 0 came to 0, 1. So we vertically shifted that point by 1 value. All right. And when you shift a function up, right, we just said you increase all of the output values by a certain number. Okay, we increase them all. We can't just selectively choose half. That would be awesome. Right? But we shift them all, right? We take the entire graph and move it. So if our example here in blue is f of x equals x squared, all right, to shift this graph up by 1, what we're going to do is we're going to add 1 to the right-hand side of the equation, right? So it now goes from x squared to x plus 1. And what you're going to notice is we just shift all of the y values by 1 here. We haven't moved the x values. Right, the x value is still the same, but now we just add a 1 to it to make this new value. All right, and something I want to highlight here is that when we made the change to the equation, we now have f of x here, and then we have this modified function g of x. All right, so f of x is our parent function of x squared, and we've now made a modification where we shift our graph up by 1 value. Okay, so that's a +1. All right, if we want to shift a function down, right, if we want to shift that function down, we have to decrease the output value by a function of a positive number, right? So for example, if we want to move the function down 1, okay, instead of adding 1 to our right-hand side of the equation, we're just going to subtract 1. We're moving our graph down, right? And then you can always do this by checking some actual values, right? So if I want to move my graph down by 1, I know that it goes from 0, 0, it's got to be at 0, -1. So I can come back in here and still plug in 0 for my x value. And when I calculate it, I'm going to have 0 - 1, which is going to give me my -1 y value, or my output value. All right. And this little tool here, I do not believe this is available to you on your iPads, if I'm not mistaken. So I'm sorry that is the way that it is. But I'll show you what this does, and that's why I'm walking you through this kinds of stuff so you can see this. So if we start off here, okay, it's just telling you to shift up and down. So this is our normal x squared. You can see that if I start moving upwards, all I'm doing is adding value. So if I go up to 5, I've just added 5. All right, same thing. If I go downwards though, I'm now subtracting from my original parent function. All right. So what is the equation when you shift the graph up 6 units? It starts at our original x squared, and then we're just going to add 6. So it becomes x squared plus 6. If I want to shift the graph down 3 units, it's our parent function x squared minus 3. Okay, minus 3. Sorry, there we go. Nope. All right. So that's what that sliding tool would look like there. All right, that's what that sliding tool would look like. So not anything too fancy, just showing you that if I go up, I'm adding, and down, I'm subtracting. All right, same thing with going left and right. Okay, but now what you can see here is I might have a function that is a little bit more complicated than just x squared. Now I've got x to the 4th minus x squared. Okay, but it's saying, what is the equation if I shift my graph up by 2 units? Well, guess what? I'm still just going to add 2. I'm still just adding 2 because it doesn't matter. Whatever my x value is here, I'm still going to add 2. Right? What's the equation if I shift my graph down by 1.5? Still only subtracting 1.5 from the entire right-hand side of my equation. All right. So again, no matter how complicated the function is, you can just shift a graph up or down by adding positive or negative numbers to the right-hand side. Okay. So to vertically shift a graph, so move it up or down, you can subtract a number from the right-hand side. Okay. And by right-hand side, we mean the side that deals with the x function, or sorry, the x variable. All right, so what does an equation do to shift a function, right? You have to add certain numbers or subtract certain numbers depending on if you want to go up or down, right? So again, if we want to go up, we just add numbers. Down, we're going to do right. All right, and this is shifting functions vertically. All right, and there's an entire quiz just on shifting functions vertically. Okay, so for example, here, the graph below has the red shape. So what is the equation of this graph here? So we got to look at our original, which is x squared, right? We got to look at our original, which is x squared. And we got to know, well, I moved down by 4 units. I moved down by 4. So I'm going to have x squared minus 4 because I've moved down by 4. All right. For this one here, it's giving you the little slidey tool. All right. So you can use this if you want, or you can notice here, if I've got my coordinate at 0, it's at 0, 0, okay? And I need it to match this blue function. Well, it looks like it just moved up by 1. So your answer would be x cubed minus x plus 1. And if you don't believe me, we can take the slidey tool and move it up to match. All we did was we added 1 to that function. All right, this graph here of f of x, right? So this is our new graph here. Okay, and what it's saying is it has the same shape as our x cubed parent graph, right? Our x cubed parent graph, right? And if we know that x cubed runs through 0, 0 here, you can tell I went by down 1, 2. I went down by 2 there. So I'm going to minus 2. And again, if you don't know how I knew that this was for an x cubed, you can go to Google, type. Oh, are you guys not seeing my screen? I'm sorry. You can go to Google, you can type in x cubed graph, right? You can type in x cubed graph. You can plug that in on your calculator, your y equals x cubed, and x cubed would run, again, through that origin point there. So since we went down by 2, we're going to have x cubed plus, or sorry, x cubed minus 2, that minus 2 there. All right, and sorry, I didn't know that I wasn't sharing my screen. So again, if this is how it started, we moved up by 1. So you could either use the slidey tool or just notice that, okay, 0, 0 went to 0, 1. So I had to move up by 1, and I'm moving vertically. All right, same thing here. I just looked at here, and I know, well, I moved down by 4, so I've got to subtract 4 from my parent function, which they're telling me is x squared. All right, so there's an entire quiz on shifting vertically. All right, and there's an entire quiz on shifting functions left and right. Okay, so now that you've shifted functions vertically, we're going to shift them horizontally or left and right. So boom, okay, if we shift the function to the left one, right, it shifts the entire function. All right, so now we're going to figure out what the equation is for that one. And if you notice here, we're now not adding it to the outside. All right, so if we were to move this function, and let me make sure I get a different color here. All right, if I moved this function, wow, that's bad drawing. If I move this function here, okay, this function would be, let's call it z of x is equal to, this would be our x squared plus 1, right? So that's what we just learned, is moving it up and down would give us this x squared plus 1, okay? But what you're going to notice now is when we're shifting functions left and right, we now have to actually add directly to the x value, okay? So this parent function here, x squared, in order to move it left, we had to actually add a value to the x component itself. So this is now x plus 1 squared, okay? X plus 1 squared, all right? And you're actually adding the unit and not subtracting. And if you don't believe me, what you can do is you can always check a point here. But if we're looking, we've got negative 1, 0. So x is equal to negative 1. Well, negative 1 plus 1 is 0. 0 squared gives us 0, right? So that would be why we're adding and not subtracting in order to get to the correct value. Because it's like saying, okay, if I take this red function, I add 1 and I'm going to shift over to this guy. All right. So then moving forward here. Okay. You're surprised you find you add 1 when you shift the graph instead of subtracting. But again, you're shifting the points. You can always check and see. So if we look at, and that's exactly the one that I just gave you, right? So if we look at this one here, all right, we went on negative 1. We wanted to make sure that it should actually be at that 0 y coordinate, which it is, all right? Now, this gave you another example here for f of x plus 3. What does the x output need to be 0? Well, it needs to be negative 3, okay? So that means when the x-axis is negative 3, the graph has moved 3 units to the left, right? Or you're at that coordinate negative 3, 0. All right. And now here we saw that we shift a function, so we've got to actually add it to that x coordinate directly. But what happens when it's not as simple as an x squared here? Okay, if we've got x cubed, all right, we can see we moved over 2 values to the left, all right? So we know we have to deal with this value too. But what we just learned is now we actually need to add the value directly to that x component. All right, so your answer is going to be C here, because I have to add 2 directly to my x, but I still need to cube the result. Okay, so we can always then check this by looking at the point. So if I have negative 2 for my x value, negative 2 plus 2 is 0. 0 cubed is 0. All right. And if you thought it was going to be b, which was minus 0, you would find out that x is -2, minus 2 is -4. -4 squared gives, or sorry, cubed is like 64, right? So it's something insanely larger than what we're looking for, which is our value of 0 here. Okay. And we can then do the same thing, shifting our functions to the right here. Except now, instead of adding, we are going to be subtracting. So for example here, if we shift 1 to the right, okay, we're now going to have x minus 1, and then that quantity is going to be squared. All right, so x minus 1 quantity squared, okay? And what this is showing you here is that g of x is equal to our original equation, f of x, but instead of having x, we're going to plug in x minus 1 for every value of x, right? And since x here is x squared, we do x minus 1, and that quantity gets squared. All right, so again, we can do this little shifting tool here. If we shift the graph 3 units to the left, 1, 2, 3, right, you're seeing we're going to add. If we shift to the right, 5 units, we're going to subtract, okay? So again, knowing the difference between shifting vertically and horizontally is the difference of whether you're directly affecting x or you're just adding on to the end of the equation itself. All right, so looking at this one here, okay, so this is a new equation. This is f of x is equal to x cubed minus x, all right? And what I want to show you is that you do the exact same thing, remember, but if we have x here, right, remember we had x minus 1, we had to replace every value of x. So you're going to do the exact same thing here. So if I move a half unit to the right, or let's just go 1 unit, okay, if I move 1 unit to, the left, all right, I have to add 1 to both of my x values, all right? I had to add 1 to both of my x values. Same thing, if I went to 2, I have to add 2 to both of my x values, right? Because again, I'm replacing x with x plus 2. All right, same thing if I go to the right here. If I shift to the right 1 unit, I'm going x minus 1. Okay, so I've got to replace both of those x values with an x minus 1. Same thing, x minus 2 if I'm shifting to the right. And so whatever I'm doing, I have to be consistent. All right, so then you can see here horizontally shift a graph, we have to subtract a number from our input variable. Another way of saying that is we have to subtract or add a number from our x variable, All right, and again, knowing that you're going to then affect x directly and not just the outside of the graph. So again, if I'm moving 2 to the left, I'm going to go x plus 2. If I'm moving 3 to the right, I'm going to go x minus 3. And you can always check by plugging in a couple points to make sure that your function is correct. All right, and looking at this here, okay, we can notice that this blue line goes through -2, 0, and the original here is at 0, 0. So what I'm going to do is I'm going to have to replace x with x plus 2. So this becomes x plus 2 quantity cubed. So your value there is d. All right, you could also use the sliding tool to help you visualize what that'll look like. All right, so now I'm trying to match my original graph to the red one. So if my original graph is x to the 4th minus x squared, it looks like I've just shifted over 1 to the right. So I'm going to subtract 1 from both of those values. So I'm going to have x minus 1 quantity to the 4th minus x squared, x minus 1 quantity squared. All right. And then knowing that this one has shift to the right, so it's no longer x cubed, it is now x minus 1 cubed. All right, and there's an entire quiz on just shifting functions horizontally. All right, And lastly here, I'll touch on this quickly here, but when you're shifting graphs vertically and horizontally, you're just combining the two steps that you just learned, right? So for example here, it says shift 2 units left and 5 units up. All right, well, we know that if I go 5 units up, I have to add 5 onto the end. And if I go 2 units left, I have to add 2 directly onto my x coordinate. Right? So you can see then, you can break it apart and go piece by piece, right? For the next one, go 1 unit left, 7 units down. All right, well, 7 units down, 1 unit left, right? It's just adding both of those components together that we've been working on, right? So for this one here, okay, if our original function is x squared, it looks like we moved 1, 2 down. Okay, so I'm going to subtract 2 from the end of the equation. So I'm dealing with either B or D here, all right? Then I've moved 1 unit left. I've moved 1 unit left, so that means I have to add 1. So my answer here is going to be letter D, right? My answer is going to be letter D, all right? And again, it's just all about, look, moving over. Close enough. Moving over, moving down. All right. It's adding both of those steps that we just worked on together. All right. So you can combine horizontal and vertical shifting to move the function of a graph literally anywhere. You can move it anywhere. All right. And we talk about it again as moving horizontally and then moving vertically, or vertically then horizontally. All right. We don't talk about moving diagonally. All right. How does it change a function? Right? Again, if we're moving horizontally, we have to add it to the x directly. So if we're moving left and right, we add it to the x component directly. And then if we're moving up or down, we just add that on as an end constant there. All right. So again here, if we go through a couple of these problems, our original is this gray line. We're at 0, 0. So I've moved up 1, so I know for a fact I'm going to have a +1 at the end of my equation. All right, I've moved up 1, and it looks like I've moved over to the right 1. Okay, so if I'm moving to the right, I know I have to subtract 1, so my answer should be C. All right, and again, to use my sliding tools, I've moved up 1 over 1. All right. For 2 here, match the graphs. Okay, so original is this gray one here, and my original graph is apparently x cubed minus x. All right, so it looks like I've moved down 2, so I'm going to subtract 2 from the end, so my answer is either A or D. So I've moved down 2, and I've moved left 1. I've moved left 1. Okay, so obviously using the sliding tool, that gives me my answer to be A. Right? And then the last one here, the graph below has the same shape as the function x squared. Okay, and this is where you have to know what the parent looks like. Okay, so you have to know that x squared is at that origin 0, 0. Okay, and also tells you it's shifted up 2 units and to the left 1 unit. All right, so you might have some problems here where it just gives you in words without actually showing you a graph. So you've got to know what up and left and right do to an equation. So if we're not looking at the graph here, if we're just looking at these words, it's shifted up 2 units. So that means I'm going to have a +2 at the end of my equation. So I'm either going to be A or D here. All right, and then 1 unit left. That means I've got to add 1 unit inside my square here. So I am dealing with letter D. All right, I'm dealing with letter D on this one. Okay, and then to briefly go over the next couple of things here for your study guide. All right. Your study guide here. All right, shifting a function is moving a function on the xy plane, right? Our normal graph. Right, the graph's location changes, but the shape does not. All right, so we can move a function vertically, up or down, or horizontally, left and right. Okay, and these here are things that you've got to just know how to do, right? So if we're shifting up, we're moving the y-axis, down, y-axis, left and right, that's on the x-axis. All right, and then we're either adding or subtracting a number from the entire function if we're moving vertically, and if we're moving horizontally, we're adding or subtracting an x to the actual, we're adding and subtracting a number to the actual x value itself. All right. So then for this picture, these pictures, this is talking about how to say this in English words here, all right? Because a lot of times you're going to be asked to work backwards from giving something that says shifted 3 units up. You've got to be able to draw me a graph. So for example here, this one is 1, 2, 3 lower. So you would say this is shifted 3 units down. Okay, this is 3 to the right. So you would say shifted 3 units right. All right. And then for number 4 here, it's based on our parent function f of x equals x squared, all right? You can know this by 2 things. 1, it tells you, right? Or 2, you can notice that it has that parabola shape, so you could probably guess our parent function is x squared, all right? And what this one's saying is it shifted down 1 unit, to the right 2 units. So again, if you didn't have this graph here, you still would have to be able to figure out how to write this equation. All right. And again, using this little chart here could be very, very helpful for you if you're getting a little bit confused about when to subtract and when to add. All right. And then we've got 5 minutes left here, so I just want to go through a couple of the checkup problems with you so that we can call this unit done here. All right. So looking at our checkup. All right. So for the first 10 here, it says write the equation of the problem. Okay, so I'll just do every so often here. And basically the helpful hint that I have here is to look at the table in the study guide, right? The one where it says, okay, if I'm moving left, I add. If I'm doing right, I subtract, right? All of that stuff. Now, clearly we can see this one goes up 1, 2, 3. So again, if I was saying this in English, I would say shifting up 3 units. Okay, moved up 3 units. So what that looks like is g of x is equal to x squared plus 3. All right, x squared plus 3. All right, for this one, I've moved down 2 units. So shift down 2 units. All right, so I take my original function, x cubed, and I subtract 2 from it. All right, so g of x is equal to x cubed minus 2. All right, now I'm moving left on this one, so I shifted 1, 2, 3, 4 units left. All right, so what I have to do is g of x is actually equal to f of x plus 4, right? So I rewrite f of x to say x plus 4 squared. All right. Same thing with number 4 here. I moved 1, 2, 3 units. Oh, sorry, that's a lie. I moved 2 units, 1, 2, 2 units to the right. So again, g of x, I just replace x with x minus 2. All right, so I have x minus 2, and that should be cubed because that's what my parent function is. All right. And I could do one more kind of funky one. We'll go with the original function is x to the 4th minus x squared. All right, so I've shifted 1, 2, 3, 4 down. All right, I've shifted 4 down. So g of x is just subtracting 4 from the entire expression. All right. And then going here to 9 and 10 here, okay, to 9 and 10. I'll do number 9 so you guys can still look at number 10. And again, these are some of the ones I talked about where you might not have a graph, so you still have to know what you're looking at, all right? So it's saying if g of x is equal to 1 over x squared, if that was shifted up 2 units to the left, shifted 2 units to the left and 3 units up, okay? So I'm shifted to the left 2 units and up 3 units, okay? Maybe I'll make these different colors so that we can see what I'm talking about. Units. So we got left 2 units and we are up 3 units. Okay, so my answer for my new equation could be f of x is equal to 1 over, since I'm going left 2 units, I have to add 2 to the x value, okay? To add 2 directly to the x value. And then I'm going up 3 units. So then I add 3 to the ending equation. All right, I add 3 to the whole expression there. All right, so you have number 10 that I would suggest you try so that you can look at what it might look like and you can still have the answer on the checkup there. All right. I know it's 9:30, so hold on one more second so I can just make final mark